All right. Hello. Happy Sunday. So yesterday we had a really great discussion where, like, in summary, we talked about like how a global state tree can be very well represented as a static tree. Like there's like one representation of it where values are either there or they're not there. When we introduce like explicit states, unions, algebraic data types, like it doesn't matter what you call them, what happens is that your state tree can like take on different shapes depending on its state. And even though that's more correct, it's harder to like build a mental image of that. And then we talked about like, what if you create branches in isolation and then React takes the responsibility of creating new branches? So you kind of fuse your state tree with the components, but that doesn't work in React because you can't instantiate anything in React because of the reconciliation loop. Or you can't at least reliably do so. Just like the... because you can't dispose. And in a state tree context, you need to be able to dispose. Like if you create a branch, you have to be able to dispose that branch because that branch might be doing side effects. But that's not possible in React reliably in concurrent mode. And then we started like talking about classes versus objects and yeah, back and forward. And one thing that's really great about do I have the repo here? Yeah. So one thing that's really great about just using objects is that as long as you're using just JavaScript, that's like awesome. But as soon as you start using TypeScript, you will always have two representations of what you're trying to express. You will have the type and you will have the actual implementation. So whenever you look at a file where you implement like a branch of the tree, you'll have kind of two implementations, one being like the type implementation and another one being the actual implementation. And the more complex the branch gets in terms of typing, the more fluff will be there. And also if you want to change something, you tend to intuitively go and change your code, and then you get errors because that's not been typed yet. So it's like the developer experience isn't really ideal. And when you want to do things like we talked a lot about nested branches being able to point back up the tree, especially for components to create like a proper contract between what components access of state. So you don't use like hooks or context providers or anything decoupled. Like the contract is the props, but what you do is that you pass nested branches to nested components. So you limit the props passing, but then you might have a nested component that actually needs state from higher up in the tree, from what was passed to it. But then it can still use that branch and then it can point back up the tree. But to be able to do that, you have to do accessing parent state. And if you're using plain objects, that gets a little bit unintuitive because you have to create this getter and because you have to create the object first. So there, and then we started discussing classes. Like the benefit of classes is that they merge typing with the implementation, which you can say is like you're putting fluff into the implementation. But at the same time, there is only one thing to read. It's the implementation. And then the other thing was like state machines. Like how do you express state machines with classes? And I did some exploring and I'm some new discoveries and some new thoughts. So we're going to explore that. And the way we're going to explore that is to like, remember that Bonsify is like an educational project. It was never intended to be something that should be released. It's just to play and learn, right? So it's really important, that context. And this is just another educational project. And then if we find something we're excited about, like we can do something with it. But the whole point of this is to just discuss and learn and explore. So what we're gonna do here is, where should we start? Should we start talking about, okay, I'm gonna show it to you first, right? Because that's better. So let's go in here and yeah, let me take you through my little journey. So I was exploring like doing a class-based version. And if you want to do this, I first explore like app, reactive, new app. So you can do this, like make the thing reactive from the outside. What was I thinking about? Why didn't I want to do this? What's the reason I didn't want to do this? Yes, sorry. So the reason you can't do this is because of the constructor. So in the constructor, you can point to this, but this, you can't. So this reactive thing is based on making the whole object a proxy. So you put the object into a proxy. So whenever you access things in the object, here it being a class instance, you'll do that through the proxy. So if I did like count equals 0, increase this.count plus plus, that would actually work with this approach, because the way you point to increase is through app.increase, right? So you're going through the proxy, making your this reference pointing to the reactive reference. But in the constructor, it doesn't do that. So this is pointing to the raw instance, and it isn't reactive. So if you were to do anything reactive in here, like set interval this.count plus plus, or you would have like this.nested equals new nested, and you would pass this instance, so that we talked about like being able to go up the tree. That wouldn't actually work. You're not passing the reactive proxy here. So you have to make this work, you have to do something like mobx, which is like constructor make auto observable this. And then and that's fine, right? You can do that. Yeah. But then, so what was I reflecting on here? Yeah, so the thing about this is like it's like there's this very appealing idea of making a class reactive, and that is being able to do something like this. So you actually make the class reactive using a decorator. This isn't possible at the moment because it can't agree on the implementation of decorators. But I was thinking about like, why do we even need to use decorators? Why can't we use, because we're going to use TypeScript, right? And TypeScript has its idea of a decorator, and the typing and everything is tied to that. But we don't really care about this being an actual decorator. So what we could do is, just like we're making all components observers of state, we can also just move this decorator, identify this decorator, and in the transpile code, it actually makes the constructor and it calls reactive this, right? And then the question is, do you use a new function for this? In the sense that, or did create a new implementation for this, so that because there are two things you have to do. The first thing you have to do is to go through here and find everything that should become getters and setters. But then if a property is an object or an array, you also want that to be observable, right? So the implementation becomes a little bit more complex than what Bonsify is. But then again, like, why not just use MobX under the hood? Because the whole idea here is not about, like, it's about removing things, removing as much as possible to just use the language. And I've been ranting about classes many times, that it's like an unnecessary abstraction compared to like having just an object and using closures. And it's that I still think that. But at the same time, when you want to build a state tree, there's something specific you want to do that classes lend themselves very well to. Like being able to create a constructor and just pass the current instance down, for example, or avoid having code like, do I have an example here? Like here, for example. So we have to define all these states first as types, and then we go in, and then we have to define the actual implementation of each type. And then it gets kind of everything that's like part of creating this state is kind of thrown into this closure. And it just doesn't, like, the nice thing about classes is that it's in terms of like navigating the code, it's not like navigating an open space. You have this root object, that's the name of the thing you're defining. And then you have properties on it being like methods or actual values. It's more structured. That's the point. But then again, I have my, like, the thing here is that you don't want to make everything reactive, right? There's certain things you want to, like, maybe you have some private variables, they shouldn't be reactive. Or maybe you're passing in some utilities or like Firebase in the app we were working on, and you don't want to make that reactive. But does it matter? Like, the whole point is to just make it transparent. So yeah, I'm not there. I have some concerns about this, but what we're going to do is we're going to try this and see how it feels like. And the idea here is like you call this decorator, and then you can pass like APIs false. And this is part of the make auto observable API, or a function of MobX, where you can say don't make this observable, for example. So there are like ways to handle this. But the thing that got me most excited about this was how you do state machines. So for example, unauthenticated. The way you handle this is that you use read only, and you can call it current, for example, unauthenticated. So that represents one state. And then you have authenticating, which is authenticating. And then you have authenticated. And here you might have a user. So you have, well, we can use a constructor. So you say public user any. I'm just going to use any. So now you have your states, right? And the type and the implementation is the same thing. But now we're going to create, auth state. It made it for me. So this is like the actual auth state. And then we can create a class called session, for example. And this is going to have a state of auth state, which starts in new unauthenticated. And what we can do here is that we can pass in this. So we can actually make session private in this case. like that. So when we actually sign in here, we can do something like, we can make it async. We can say this.session.state equals new authenticating. We do something, and then we say this session.state equals new authenticated, like this. So this is all you have to write to do like a state machine. And it's way less code. Like there's fluff here. Like the read only is fluff. You have like private, public, read only, that kind of stuff. But it's, at the end of the day, I think it's more precise. Yeah. So that was kind of the thing that got me, okay, maybe there's something to this. But anyway, so what we're going to try to do is, first of all, I'm going to build some stuff here. So that would be reactivex yarn install. And then we're going to go to the bubble plugin. Let's do a yarn install there as well. Lukker du døra, Emma? Kan du være snill lukke døra til kontoret? Takk. Den døra, takk. Let's see. Oh, God. Oh. Yeah, I guess that's fine. So we're going to try to create bubble plugin that actually creates that thing. Oh yeah, I guess we don't need the tests here for now. Cool. And we're going to use AI for this. We're definitely going to use AI for this. Can you create me a bubble plugin which identifies decorators on classes like, and we're going to do the simple one first, like without that option object. So it's going to be reactive, but we can still call it, right? Class app. It should remove the decorator and rather introduce it as a function call in the constructor, like and then constructor. It's kind of nice what they've done here. When I'm typing here, it's auto-indenting. When I write code, it's really awesome. So this will be reactive this. The call to reactive in the constructor should happen on the last line of the constructor. Only create the constructor if it does not already exist. Like this should, in my theory, as we've been hammering these AIs with bubble plugin stuff, it should be able to build this quite efficiently, I think. And then there's a call to the end of the request if it doesn't exist, except. So there was a, yeah, we could maybe use a body. Oops. So I am getting an error on that body does not exist on constructor method. Cast the body to a block statement before accessing it. Okay, this seems to be. This code still states that body does not exist on constructor method. Yeah, I probably got confused that it was body. Okay, cool. So we can try to write a test for this. Let's actually bring back the tests here. So we're not gonna, just gonna call it. And then we actually don't care about JSX here, so we can drop that. Transform, let's remove all the other tests. And what we want to transform is reactive class app. And then this should become without that one, with this one. Constructor. Yes, reactive this. Something like that. Let's see. And it failed because what? Oh. Oh, that's interesting. Oh, so it's not able to even parse it. Oh. I thought. But if I transform the code first, shouldn't, and I remove the, but it's a parsing error. Oh, maybe there's something going on in, how do I make bubble parse decorator syntax? That kind of sucks. Okay, so let's just add this. Where was it? So I guess we just need to install this. That's interesting. And I wonder if, so SWC should be able to parse it. I guess this is for, this will actually become a dependency. Okay, let's try it again. Oh, interesting. Oh. Oh. But why does plugin proposal decorators, what does this do? Ah, this is way more complex than I thought. This sucks. This really sucks. Yeah. So I added the plugin now, and it actually transfer. What I don't understand is how that plugin works, because we don't actually want to transform the decorators. Bubble plugin decorator. We just want to remove it. So I wonder how they do that. Because they seem to... Oh my goodness. Because why didn't my plugin work? Because I'm telling it to remove the decorator. So it shouldn't be there even when, but it says it has a parsing issue. So why is this able to parse decorators and not? Like I would think that's like inherent of. Okay, let's just ask it. You know what? Maybe it actually knows how to do this. So we're gonna. So let's ask the AI. Maybe it's able to. So my test fails with, but the whole point of my plugin is to remove the decorator. Why? So why is it? There is a plugin called bubble plugin, which is able to transform decorators. Why cannot my plugin do that? Maybe it knows. So parser must be configured to allow decorator syntax. No, that's not what I wanted. Discard. But I do not want to include that plugin because there should not be any need to transform the decorators. We just want to identify them in the code and remove them. Maybe the plugin doesn't. Maybe the plugin actually doesn't. Oh, it says but this is weird. Remove. Has reactive. This is like has reactive decorator. I don't think it actually removes it. I think that's why it's erroring. It's just identifying. Is my play. I think what happens is that it actually does what it's supposed to, but the resulting code still has a decorator. It doesn't actually remove it. Oh no, wait, it's filtering. Sorry. Oh, that's what's happening. Oh. But I do not want to include that plugin because there should not be any need to transform the decorators. We just want to identify them in the code and remove them. Why does it error in the first place? Why is that other plugin able to transform decorators and not mine? Wow, it's super fast. Yeah, well, parsing happens first. Yeah. Okay. Is it possible to include in my plugin telling the parser how to parse the class the class decorator that I am removing? Interesting. Manipulate options, which allows them to modify parser options by adding decorators legacy. Oh. Okay, interesting. Hey, and it works. Look at that. Awesome. Yeah, it should, like, theoretically it shouldn't have been like a big issue. Okay, so let's build that. And what we are gonna do now is we're gonna put on some music. And then we are going to, by the way, I only have like an hour, which means we have like 20 more minutes, 30 maybe, if I push it. So what we're gonna do, we're gonna create a link of this, and then we're gonna go to reactivex, link, bubble, reactivex, and then we're gonna add another. So I'm calling this plugins here, bubble plugins. I thought about like implementing this in the observer plugin, but the observer plugin should really be its own thing. Reactive plugin from bubble plugin. Oh, fudge. I forgot to rename it. No, I didn't. Look at me being all proactive. So we're gonna add this. Cool. And then we're gonna yarn build this. Oh, yeah, sorry. So I need to copy over some stuff. Where is Bonsify? tsconfig. Rename to CJS. That's what I need. Yeah, I think we can just rename it to rename. Let's see, reactivex, blah, blah, blah. We don't really care. Let's see, bubble plugins. Yeah, and this one's not really created yet. Okay, let's try to build it now. Oh yeah, now we changed dependencies, bubble core. Yeah, I think we can just yarn install. Might have to link it again. Let's make sure we do that. Oh yeah, yarn add mobx. Oh yeah, yarn add mobx react light. So like conceptually what this would look like is it's like it uses mobx under the hood. It uses the observer package, and then it does this decorator transformation. And the result of that is like you can start a project, you import reactive to make a class reactive, as opposed to importing reactive to make an object reactive. So you use it like a decorator on a class instead of a function on an object. So it's the same simple like idea of a single primitive. And then it doesn't export anything else from mobx. No, nothing computed, nothing like that. So it simplifies the whole concept, and then it's more documenting how do you do state machines, how do you ensure parent state access, and how do you create contracts with components and all of this stuff. Let's see, let's build again. Cool. Yeah, just yarn link bubble plugin reactive. Thanks. Cool. So what we're gonna do now is we're gonna, I think you've done your work. Thank you, AI. We're gonna create now a Vite project. I'm so looking forward to what they're working on. Project name, Vite demo. It's going to be React. It's going to be TypeScript. We're going to use Babel. Yarn. Oh, did I create a link? Let's first link ReactiveX. Yarn link. Vite demo, yarn link. I really like the setup I have now, like linking packages and stuff. It just works, which is super nice. So what we're gonna do here in the demo is we're gonna go in and say import ReactiveX plugins from ReactiveX Bubble plugins. So Bubble plugins. Yeah, and I guess we can do this. And then we should theoretically be able to let's run it first. 5173. Do we have the old one here somewhere? Yeah. Okay, so we should be able to say class app state count 0 increase this.count plus plus, and then we'll say const app state equals new app state, and we say app state.increase, and we say app state.count, and of course now it doesn't work, but in theory, if I now do reactive from, I think there's a type error here. We're gonna look at the type errors, but in theory it should work. It didn't work. Yeah, like the speed of 03, I was blown away now. Like it was insanely fast. Well, like even faster than 40, 04. But yeah, funny enough, this actually did work. But it's interesting, right? To have that experience of just, okay, I'm happy we got to this. So now I can at least end the stream with a working demo. But yeah, as I said, like just let's do the summary first, and then we're gonna fix the typing because I have some thoughts. But the point is that it would be so nice to have a state management library that doesn't flood you with abstractions and primitives. It's like you need one primitive, and the only thing, like the only primitive you have to have is a primitive that creates reactivity. So as I said, we just flip from doing like passing a plain object to a reactive function to calling a reactive decorator on a class. But the idea is exactly the same. And then it's like the things that I don't like, nothing is a silver. There's nothing like a silver bullet. It's only trade-offs. So what we're gaining now is being able to express this state tree using classes where you kind of bring the typing and the implementation together. But doing so, you will have more. Sorry, I got a notification. So the good thing is that you kind of overall reduce the amount of typing, and you don't have like two different representations of your implementation, like the types and the implementation. But you are introducing new things like read-only, private, public, stuff like that. But yeah, what are we gonna do? Yeah, I want to fix the typing here so it kind of becomes an actual working thing. So yeah, that's like the trade-off. And like when I've been dissing classes, it's really been in the context of like React doesn't use classes, right? It's just functions and objects. And it would be nice to keep that paradigm. when you do state management. So that's another thing. It's like now you have a class-based state management versus like a functional-based component architecture, or whatever you want to call it. But maybe that also makes sense because state management is very different from building composable UIs. So I personally wouldn't have an issue flipping between these two models. But maybe other people sees that as a problem. But again, we're not trying to solve everyone's opinions and whatever. But yeah, okay. So let's see if we can fix this type issue. So what I see from, so what I'm doing here, the actual, this is the whole implementation. So we're using MobX and we're turning off the enforce actions, because if we enforce actions, you have to use like generator functions to do asynchronicity. I don't think this is a good idea. I think if you want to protect state, you can rather make in a class you would make certain state private, so it's not accessible by the outside, right? And then you like it's like you do in any class. Where's the thingy? Where is it? So vdemo source app. So if I didn't want the count to be changed from the outside, I would do a private count like this, and then we do get count return this.count, right? And then we would change the internal count. If you really want to protect something, that's the whole point. But yeah, so but I don't think like protecting things is more about conventions and a common understanding of how you write and do state management. It's not like enforced by the runtime. That just seems weird to me. And if it happens, it doesn't break anything. If someone changes the count from the outside, it doesn't break anything, like in the sense that the count goes stale in one part of the app. Like the whole system is still reactive. But what happens is that you're doing changes to that state from multiple places. But that can be fine. Often you only make changes one place. So it's like, yeah, but this is very theoretical. Anyways, let's go back to the thing. Like it's the kind of thing when, like, socially, like you feel you have to do something because someone said it should be like that. But personally, you don't care. And you think you're fine. Like it's kind of like like with our kids, we tell them all the time to put on their jackets or you'll be sick, right? And they're like, we'll probably be fine. And they're right. You can even argue, I researched it a little bit, you can even argue that your immune system actually gets a boost by suddenly becoming cold. Like your body suddenly becomes cold. It boosts your immune system. It's like the prolonged feeling cold that can make you sick. So it even like, so when they're running over the playground outside here to go to a friend, it's actually boosting their immune immune defense or the immune system as they enter potential bacteria at their friend's house. Anyways, so the whole point is, yeah, I feel like this protecting state changes is very much the same. But and And also the point is, I guess maybe the problem is that the system is reactive. You don't notice that you're doing something wrong. So for example, with JavaScript, you can change anything, right? Even in Redux, you can't guarantee that you try to make changes within the reducer. You can point to any object returned from a reducer and try to change a property on that object. It's just that nothing happens, right? But in this case, it would actually like trigger the reactive mechanism. It would keep things up to date, and you would think that everything's fine. And then at some point, someone's like changing something, and then like changes so that the count, like the increase method for the count, does something additionally. And then sometimes that doesn't work. And the reason is that not everyone's calling increase, right? Some call site is not calling that. But again, with modern tools, it's like you can very easily right-click that count and do find all references and just fix it. You can make the count private. Like if you really want to protect it, you can do it. So it's the whole discussion we had about like, do you have a free model and create guarantees and encapsulation and guarding and all of this stuff where you actually need it? It's kind of like testing. You ship fast, and then if something breaks, you write a test that ensures that that thing never happens again. You don't like proactively write a shit ton of tests for things that will never break. Like it's a test that's written proactively is a wasted test until it actually protects you against breaking something. And the point is to move fast so that when there are bugs in production, it takes literally minutes to get it fixed. That's where you want to be. It's not where it takes 2 extra months, I'm exaggerating, but 2 extra months shipping something because you want to make everything perfect. And like, again, I'm coming from the startup world. So what we're trying to do, fix them. So there is this, let's see, TypeScript class. This is decorators, right? Where is it? Docs, decorators, class decorator. I was looking at this earlier. So I believe this is the actual, so what we're going to do is we're going to type this as something else. So we're going to say, well, let's do this first, but we're not going to do constructor. Let's see, what the hell is this? So I'm not sure. Void? Is it void? Then we can actually test it here. So class app reactive. So the reason I want to pick up the T here is because of make auto observable. Overrides would be, what's it called? Annotations map. So I want to make an annotations map out of T, and I think I can use never here. So that's going to pick up, the point is that this is, if I put an object here, it's supposed to pick up the actual properties here. But it's picking up prototype, and I think it does that because this T is like, this is literally the prototype. It's not the, oh yeah, this is the thing we actually want to pick up. What it actually returns. Yeah, exactly. So what we want to do is, I'm going to ask it. I really want to get, well, I guess I can do U, U extends. Well, I guess we don't care. And then we say U. Oh, that doesn't work. Yeah, I was hoping to kind of pick up the... Okay, let's ask it. I am trying to pick up the type of the actual class in this decorator type. But maybe it doesn't matter that much. Yeah, you know what? That was a really bad explanation from me. I want the U, what's it called, generic here, to be the actual type of the class. How can I do that? Instance type. Okay, does that work? This is pretty awesome. Can you believe it? Oh, that's pretty awesome. But I guess it also brings in like increase here if I do that. But I guess that's fine. But okay, so now that typing actually works. What did it actually do? It says any instance type. Oh, it's an actual thing. Oh. Yeah, and then we could change this so instance type T, and then we could go create like so that it only picks up actual observable values. Like we don't care about the methods. And the point is that you can actually say false there, but we also need to fix like the bubble plugin to actually handle that. But yeah, it's kind of cool. It's kind of cool. Oh. Where is the, let's see. Where's the plugin? No, the demo. There it is. There we go, reactive. Okay. So what would we do from here? I think first of all, I'm gonna push this. And then I'm gonna play around with the documentation. Yeah, I'm gonna kind of implement the documentation that's from the other project and just see how it looks like when it's class-based. And then I would love to, like, again, I hope this like brings up discussions, feedback, what people think about this, and especially like why not just use MobX? And you could definitely just use MobX. Though then you have to use like make auto observable in the constructor functions. And you will kind of have everything exposed to you, like computed and everything. Because there is an argument here to make reactive much lighter weight than MobX. So it only interacts with properties that's actual like JSON state. But maybe that doesn't matter. As long as it works and it's performant, and everything's behind the scenes, right? This is the whole point. You should just write code. You should not describe the reactivity of your in detail. Like, that's what I don't like about signals, is that you literally describe the reactivity in your code, but you don't care about the reactivity when you write code. That should be like transparent, in my opinion. Ideally, it should be transparent. So I guess we're kind of really reaching for it. Like, how transparent can we make it? Like, we could even remove this and we could say like any class in this folder becomes reactive. And then you don't even have to use the decorator, right? Could make it super transparent. But then again, you aren't able to like say, oh, this certain thing, I don't want that to be reactive. Okay, I have to stop the stream because I promised my partner that I would do this for an hour. Actually, I have, looking at the timer, I actually have 3.5 minutes left. So we're gonna ask the Babel or the AI again. I want the reactive decorator can take an argument of class app count equals 0, reactive count false. I need this argument to be passed on the transformed call. So that would be reactive constructor. Wait, what happened? Stop. How do I? Oh, thank you. Reactive this. Let's see what it does. Declare variable reactive options to store the decorator argument. Inside the decorator filter, if the decorator is a call expression for reactive and has an argument, assign that argument to. Okay. So reactive options. Oh yeah, it's just yeah, it doesn't matter. This is a silly. Let's just do any. Okay, let's write a quick test and then we're gonna quit. Oh, transforms class reactive decorator. Transforms with options. Count equals 0. So this should be reactive count false. And I guess we need to add count here. This probably fails, but it could be just me. Yeah, it's just. We did it. Oh, and the count is underneath. Doesn't matter. There we go. Nice. Okay, let's push this as well. Handle options. Okay, cool. I'll leave you with this, and please reflect. What do you think? What's your experience? I really want to learn and discuss. Yeah. Bye for now.